welcome for our first act of this evening. Put your hands together and welcome Scott to the stage!
Hello. Hi, my name's Scott and I'm a material scientist. For my talk, I'd like to do something you've probably never seen before. A guy standing on a stage in front of a massive room of people and saying quite loudly that smaller is better than bigger. That's our second penis joke of the night. Things have really kicked off. Now, I want to tell you about the materials of the future, how we see them, how we build them, what they are. And to do that, I'm going to tell you a little story. Okay? If you'd asked me 10 years ago what I wanted to be, I would have said a scientist. I'd grown out of my phase of wanting to be a superhero or king of the earth at the age of 12, 18. And I knew I wanted to be a scientist. But it wasn't materials I ever pictured myself studying. It was this. This to me was science, space. I used to sit as a little boy, look up at the sky and think, wow, that is so cool. It was so unknown. I just wanted to know everything that there was to know about this. So I started studying science. I learned a little bit more, and it was even more amazing. The physics and the science keep me here, keep planets orbiting each other, keep galaxies together. That was pretty cool. But as I got a little bit older, I realised I was being a little bit naive. When I was taking my smartphone, I was staring up at the skies, I was using the app that tells me what stars I'm looking at. I was going, wow, look at that science up there. And I was totally missing the science I was holding in my hand. The science of the small world. The world you can't see that exists in the tables, the chairs, the beer, and all of us. It's there, we can't see it. And it's just as exciting, it's just as cool, and it gets me all giddy. So that's what I'm here to talk to you about, stuff like this. But we need a sense of perspective of how small this small world is. So we're going to start from the bottom up, quite literally, your bottoms, okay? Everyone here is sitting on a chair, okay? Common sense would make you think that you and the chair are pretty much touching. This is as scientific as it's going to get, so keep your seatbelts on. Actually, if you look at the scale that we're hoping to build the new devices on, you're actually not in contact with the chair. The stuff that makes up you and the stuff that makes up the chair is actually apart. You're separated. You're hovering. Not just the people who are needing the toilet who are hovering quite a distance. You're actually hovering a tiny, tiny, tiny amount. What I want to show here is how different the small world is to what we're used to seeing in our everyday lives. The fact that you're not actually in contact with this chair is the only reason why you don't take the chair away with you when you leave tonight, unless you steal it. But this is the kind of scale that we were interested in designing stuff in. But designing what? Doing what? So we're going to build a computer. Okay? And you are going to be my computer. Okay? Let's imagine we had two switches. Okay? If the two switches are on, everybody in the room is happy. So let's see your happy faces. Everybody's smiling, everybody's smiling, everybody's smiling. Okay? Remember that. If both switches are off, which we will demonstrate by being down, everybody in the room is sad. Let's see your sad faces. There you go. Sadder than that. Yep. You've been sad the whole talk, I don't know what you're doing. Okay. If only one of them's up and the other one's down, everybody's shocked. Let's see your shocked faces. Yep, very good. And if it's the other way around, you're kind of confused, you're kind of drunk, you're not really sure. Some people vote like this for the full talk as well. Okay? That's basically all we need to build a computer. So if I were to say to you, how are you feeling when you see this? Let's see your faces. There's some confused faces over here. There's confused faces over here. Some confused faces over here. You're supposed to be sad. That's basically what a computer system does. It reads what you're seeing and tells you what you're supposed to be. That's basically all you need to do. Anyone know what this one is? Confused? Yep. What about this one? Very confused. Okay? This is basically a bit more what a computer's like. There's lots of these switches, times millions and millions and millions, all on computer chips. You don't need to know what they do. You don't need to know why they do what they do. You just need to know they do something The only thing that controls like what the computer chips do and how our phones do more things, how our iPods hold more phones, is how many of those tiny little switches you can get onto this. The more you can get onto it, the more it can do, and you can become Bill Gates, be loaded. So there you go. Go away tonight, build a computer system, and it'll all be great. So, if we wanted to build these tiny, tiny little things, we need to have a sense of perspective of what can we actually see at a small scale? What's the smallest thing we could possibly ever see? Okay? The idea that life and everything, the tables, the chairs, the roof, the lights, are all made up of tiny little things has been around since the Greeks. They thought of it. It wasn't until the 1800s that we actually found or predicted the atom. The little Lego of life that builds up everything. You're made up of it, the beer's made up of it. All you need to do is take these and you can make anything. But can we see them, is the question. Could we build stuff on this scale? How would we see them? Good question. Thanks for asking that question. When I was younger, I would assume that if you wanted to do something this small, you just need to take a big telescope that sees stars that are miles away, tip it upside down, look at your symbol, ta-da! You've got it. Technically not how it works. Even light is too big to see these tiny, tiny little building blocks of life. If we wanted to build stuff and see them on this scale, light's too big. It'd be like throwing a house at a pea and trying to see the pea. Well, you'd squash the pea, obviously, but you wouldn't see it. You need something even smaller. So if our atom is our cosmic planet in the little atomic world, the little orbiting planets are called electrons. These are the things we're going to use to see these tiny little things, because they're even smaller. You want to see something small? Use something even smaller. There you go. That's as difficult as what I do. So we take these electrons. Every time you turn on a light, electrons come flying out. All you do is get them, fire them through a material, and like a comet that goes through the universe, every time it passes a planet, it turns, shoots, sometimes it smashes into them. Every time it does that, you know there's something there. Basically, that's what we do. And don't take my word for it. Here they are. The building blocks of life, the tiniest little thing you possibly see on a scale down here, 5 nanometers. Probably means nothing to some people here. A nanometer is how much your fingertip or your fingernail grows in a second. It is minuscule. So every time you bite your nails, look what you're ruining. Look how beautiful that is. So this is this kind of scale that we'd want to build. Small devices. If we could build stuff, just a few of these across that way, a few of these across that way, you could fit millions on the side of the chip inside your computer, inside your phone. It could do loads. Can we do that? Are we getting towards the way of being able to do that? How will we do that? Yes, we can. This is where 12-year-old me gets very, very, very excited. Very, very excited. Whenever you see this sign, you get excited. Any door that has this on it is a good room. You know that. Lasers. As I said, building blocks of life, everything's made up of this Lego. If you wanted to make an even smaller thing from a big thing, fire a laser at it. You take your material, fire a laser, smash out all your Lego, and catch it somewhere else. And that's it. The people in my department would not say that's just it, but that is basically what I'm saying, it's just it. So, if I could go back to 12-year-old me and tell him one thing, it would be, if you spend all your time looking up, you're going to miss all the cool stuff that's happening down here, which is pretty cool. Thank you very much.